Welcome to Live at Lunch. I am delighted to have a special guest, Donna the Astronomer. Now, what do we call you? The official title at Milroy? You're the lead astronomer?
I'm the head astronomer.
Head astronomer or
yeah.
astronomer in charge?
Yeah.
She's the boss, no matter what it is, and
Exactly.
very, very knowledgeable on the night sky. And so I've asked Donna to join us today and share all about Australian hidden figures or Aussie hidden figures. And if you've watched the movie Hidden Figures, it's fantastic. If you haven't, go and have a look. And it's incredible about mathematicians and engineers who are women who actually help contribute to launching men to the moon. And they were hidden. They're quite fantastic mathematicians. Have you ever actually seen the movie, John?
I have seen the movie.
Yep.
Yes.
I've read the book. The book is nothing like the movie. It's all.
Do I need to read the book?
It's really quite different. It's really quite different. The movie comes from it. It's more about the journey of Negroes in America, and you know the plight that they're. And I honestly believe they still are. If you really watch politics, but also NASA. So there's lots of stats and history before NASA was NASA, and the progress over time. So there's quite a few targets of lots of different women more that's in the movie. But the movie portrays that story.
Pretty amazing ladies.
Yeah, incredible. So all right. So let's get into sharing all about the amazing knowledge that you've been researching. It's quite fascinating, Donna. It started off at International Women's Day, didn't it?
It did, yes.
And you've done another presentation for the Rural Woman when we came at the Full Bloom program in Baradine.
And for NACA, the National Convention of Amateur Astronomers in Australia.
Ah, yes. You did that.
Yeah, I did this talk there as well.
Okay.
So getting the message out there.
Yes.
So often Australian ladies are lost in the history.
Yes.
And Australian astronomy in general is lost to know that what actually happens.
Yeah, and there's lots of massive behind-the-scenes work when you're researching things like what's out in the sky.
Yeah.
So
it's
you don't always
interesting.
know. Yeah.
And you find things in the most weirdest of places.
Yeah. All right. Okay. So we're going to head over to the presentation.
Okay. Well, the way that we look at the night sky has been influenced by women over the years, and we're talking about many centuries BC. And some of their names we don't know, and certainly some of the names of people I'm going to talk to you about today from Australia, most likely you won't know. Some you may, some you won't. But many of these ladies pursued their passion for the heavens and the skies long before they were accepted and recognised by the appropriate bodies. And many of them published under their husbands or their partners or their fathers or their other relatives' names. And it's certainly not just the story of astronomy, but it's the story of how women have had to rise above just the political and every other sort of environment of the times to actually do what they want to do and how they want to do it. So even today, we only make up 15% of astronomers worldwide are women, but what we lack in numbers, we certainly make up for an impact. So this is a quote by Dorothea Klumpek. She was the director of the Bureau of Measurements at the Paris Observatory in 1899. And what she wrote is that ours is a work of the night and day. Astronomical science now becomes universal. She knows no boundaries, no rank, no sex, no age. And this was at a time when photography was becoming popular and was making so many changes into astronomy. And women were ideally set up to be able to do this because we have the skills of concentration, attention to detail, and we're prepared to work hard. And that's what she was getting at. And right across the world, when this sort of science that we're going to talk about came into being, women were the right sort of people for it and were actually then able to get their foot in the door. However, they weren't recognised as scientists. They were named computers, they were named measurers, but it was some time before they'd actually be acknowledged for the work that they actually did. So this is a picture of the very first observatory in Australia. Now, contrary to public opinion, the very first observatory in Australia in modern history was from the French, from La Perouse. And this is very similar to what Captain Cook used in Tahiti when they were doing the observations over there for the transit of Venus. But just a little bit of history. We're going to go through a little bit of Australian astronomical history because many people don't know it, and then how we ladies fit into it. So the thing about the Australian skies is they are so different. So this is a picture about this time of the year showing the Emu rising and the large and small Magellanic Clouds. And these were things that can't be seen in the Northern Hemisphere. So there was a great interest in the southern skies. Some work had been done in South Africa by Herschel and the like, but Australia had better skies. And so in the fledgling country, because we're talking the end of the 18th century, when astronomy was still relatively new and telescopes and that were pretty incredibly growing. So this is just a pretty picture because I could put it there. Okay, so the first European astronomers, and I'm emphasising European because the Indigenous Australians have a history going back at least 20 and some say 60,000 years, but they didn't do it in the way that we in Western science talks about. So the first fellow, the first official astronomer, European astronomer on Australian soil was Charles Green. He was the astronomer with Captain Cook, and he took astronomical observations on the 30th of April in 1770 in Botany Bay. And he went on to die of scurvy and similar things and overindulging in rum in 1771.
As you do.
Exactly, in those days. So that was then. And so the second astronomer on Australian soil was Joseph Lepart d'Aiguillé. Now, my French is horrendous, as you just noticed, at a place that's now known as Frenchman's Beach, which is probably appropriate, near where La Perouse is, and on the 20th of January 1788. He set up his observatory there. And this was about the time when Arthur Phillip had gone to Botany Bay and decided it wasn't exactly acceptable, and as he's leaving Botany Bay, the French are arriving. Yeah. And this was before the big war and the Bastille Day and things like that. So the French and the British were a bit far away from the battles, and so there was a lot of communication between the two, even though it was very difficult to go backwards and forwards. Sounds very simple today to drive from La Perouse to Port Jackson, but it wasn't. So that was the... So he said there, and they were lost at sea a year later. And if it wasn't for the fact that they met up with William Doyle, the first Australian astronomer, the first British astronomer, we would have none of their history because they were lost at sea off the Solomon Islands later that year. And all the documentation would have been lost, except for the fact that the French astronomer wrote to William Doyle because he was much more, the French fellow was in his 30s, so he was much more experienced to give William Doyle that sort of advice. Yep. And so William Doyle set up at what he called Point Massacre, which we now know as Dawes Point, and got the observatory up and running, and as we'll see, made a great influence on it all. Unfortunately, he had to return to England in 1791 and his observatory fell into disarray. And nothing really got done officially in the settlement then until Sir Thomas Brisbane arrived in 1821 and was only here for the 5 years. So he set up the observatory that's at Parramatta Park. He was a very keen astronomer. He brought with him two fellows called Carl Runker and James Dunlop, who went on to become very important names in Australian astronomy and catalogues and everything else and things like that, which is really interesting. So this is a picture of Dawes Point as it was then, and Point Massacre. And Dawes Point Battery is right at the opposite end to where the Opera House is today. And so you've got the map on the other side showing you Circular Quay and everything else. And I went down looking under the Opera House for the plaque and I actually found it. Right. But I couldn't find my photo of it. So I thought that was quite interesting. So just showing now, and you can see where the Sydney Observatory site is and why it's not exactly good for science these days. But yeah, so I just thought it was a bit interesting. But here we come into Elizabeth MacArthur. And so basically to do astronomy or science in these days, you needed to be married to somebody important. Or the sister or the daughter or somebody important, as you'll see. And, of course, Elizabeth MacArthur, of course, was married to Governor MacArthur. Yes, she did all the work. Of course, in more ways than one. That's why she has, all those things named after. So she was actually Australia's first lady scientist, and she was the first soldier's wife to arrive in New South Wales. So prior to that, the women who were here were convicts. Yeah, so Elizabeth MacArthur was pretty amazing for a lady. And as I said, because she was married to the governor, she had lots more rights. She was very much interested in botany as well as astronomy, and she worked with the astronomer William Dawes. But she actually has been recorded. There are actually written records of her measuring the motions, distances. So she wasn't just looking through a telescope and, having a good time. She was actually doing real work at the government observatory, which was, as I said, at Dawes Point and was pretty primitive. Yep. But she'd travel across there. And you have to remember, it's not as easy as it looks today where you could just walk around.
Yeah.
Because it was still being
With
developed.
bush and,
yeah. And William Dawes, of course, was also a surveyor. He was a surveyor general. So he also was planning up the streets. So by day, he was setting up the streets and everything else in Sydney town, as well as by night running his observatory. And it was a pretty long walk from there to there. It's a pretty long walk today.
Yes.
But you're in the bush. And so she'd go out there every night and work with him and do this work, which I think is pretty amazing. So again, come to a fellow, George Smalley. He was the second director of the director of Sydney Observatory. And he was the son of a Church of England minister over in England, and he got trained over in England and everything else, and he became the government astronomer in Sydney. And what he really wanted to do is he wanted to see more women get involved in sciences. And I mean, at a talk to the Royal Society, he made this statement: "A knowledge of science in ladies is not inconsistent." Mind you, this is a little bit paternalistic, but let's accept it. Yeah. With their natural refinement or incompatible with their usefulness in domestic and social life. So, a bit paternalistic, but it was so much advanced on everybody else of his time. Yeah. Unfortunately, he died 2 years later. Otherwise, we would have probably seen a lot more advancement in women being able to do things, because it was to now become 70 years before women would be accepted into the Royal Society. Yeah. So, here was a guy who was ahead of his time, but unfortunately died too young. Yeah. So we come now to a society astronomers, and these are women who got involved in the societies of the time, but they couldn't become full members. In fact, the three ladies didn't become members until 1893. Right. And then they were just associate members. So for most of the 19th century, science in Australia was closed to women. Yeah.
Well, 1893 sounds fairly forward compared to perhaps lots of other places.
It does. Remember South Australia was the first place to get suffrage to women. And I've learned all this interesting stuff doing this. And it wasn't until 1890 that women could even go to university, let alone study sciences. Yeah. And so they could a lot of women did. They undertook astronomical activities, but because they were wives or lovers, or there were a lot of lovers. Right. They were interesting times, daughters and the friends of male astronomers. I mean, and Todd, the daughter of Sir Charles Todd, the famous fellow who built the Inland Telegraph. Oh, right. It's from South Australia. Like Todd River. Yes, famous Todd. Okay. Very famous in South Australia. She did large amounts of work, but they could only get recognised in the community because of their connections, like we talked about, all of those folks. So it's one of those problems. So here we've got comet watchers and amateur astronomers. So on one side we've got Alice Todd, and on the other side we've got Lorna Todd. So these were daughters of Charles Todd, who were able to make observations and do things on the basis of the fact
their connections.
And they were ultimately able in 1893 to join the Astronomical Society of South Australia. But then came along something that was to change everything, and it was called the carte ciel. Now, again, my French is horrendous, but this was an astrographic catalogue. We just got into photography. So photography was new. And I mean, it's really hard for us with our mobile phones and taking pictures everywhere to remember there was a time when there wasn't cameras. Yeah. And they learned how to use cameras on the sky. And this was done in South Africa on a comet. But by now, because the southern skies were so unique and everything else, Henry Russell, who was the director, and for many years he was the director of Sydney Observatory, signed the colonial observatories up because, again, Sydney was kind of the unofficial capital. This is pre-federation of Australia. And to carry out the Southern Hemisphere part of the astrographic work on this carte ciel. And it was only planned to last a few years. But like many government projects, of course, it went over time, over budget. In fact, it wasn't complete until 1964. Right. A little bit over time and over budget. But it got women in the door. Yeah. And that was what was really incredible, because this was the sort of work that women could do. Yeah. And there's a few reasons, as we'll see, for that. So measuring astrographic plates provide an opportunity for women to get involved in astronomical work.
So astrographic plates are like photographic
They're
plates?
like photographic plates. Yeah. And there's lots of measurements to be done. So there's some mechanical measurements done, but most of it had to be done by eye. Kind of like what Rob Gordon and I used to do with the comets and asteroids. Right. We used the computer to do a lot of it, but the human eye is so much more accurate at picking up those minor differences than that. That's why they were doing all this searching on Stargazing Live last night for the supernova, because many eyes see many things.
I understand they found two.
Yes, there's so much data out there. Hopefully they'll find some more.
Yes.
It's going to be very interesting, the outcomes of all of that. So the positions of stars are measured by eye by the astronomer peering through the telescope. This is how it used to be done, which meant you could only look at a limited number of stars. You could only look at one star at a time.
Yeah.
And you could only look at so many stars in the night.
Yeah.
And then it depended on your eye, how consistent, how you saw it, the seeing. But along comes photography, and suddenly you can look at thousands of stars or hundreds of stars at a time, and it's consistent, it's repeatable.
Yes.
So even with weather and that, you can
because you can hold it still and watch it and look at it.
Well, you take the picture, and then you look at them later. Because when you're looking with your eye, you know what it's like. You were looking at the moon last night. It wasn't easy to keep looking at that moon for 10 minutes. At the gaze
it was
things.
hard on the neck.
So photography gave us an amazing ability to detect also stars that are too faint. When we look at the stars, even in our dark skies here, we can see 6,000 stars.
Yeah.
But with cameras, we can see 10, 20, 30, 40, 50 times that many.
Yeah.
And as cameras have progressed and we put them on telescopes, it's amazing what we can see.
Yeah, amazing what we can see from your Milroy Observatory.
We saw that night, which you can't see with your eyes.
Yeah.
And so by the event camera meant you could do this. So they designed a special type of camera called an astrograph. So photographic plates were exposed to starlight to produce images of the sky, from which a catalogue was eventually compiled. But as I said, it went a long, long time. Okay. So the Sydney Observatory used optical plate measuring machines. And so this allowed the position of the stars to be really things. So we measure stars have like latitude and longitude on Earth. We measure the thing called RA and depth. So it gives an exact position where a star is in the sky. Now, of course, the sky appears to move because the Earth's moving, both on its axis and then around the sun. But these addresses pretty much stay the same.
Yeah.
Okay, and so it's really important because that way you can identify what's where and when. So when you find a supernova, there wasn't a star there before.
Right.
So you have an RA and depth position and you see what it's like, and then suddenly you've got a new star.
Yes.
Which could be a nova or supernova or in my case a comet or whatever you're looking for.
What did you say it was an R&D?
RA, right ascension, and declination.
Okay, so it's a bit like latitude and longitude on the Earth, but
right
it's whatever's out.
Is latitude, and declination is longitude.
Where's the starting point?
The zenith, I guess. So in the sky. So you're looking out. Sorry, no one can see me, of course. But
I've actually got it on
my hands out. So you're like this, stretched out.
Yeah.
And so you've got from that horizon to that horizon.
Yeah.
And obviously you're in three-dimensional space. So you've got the altitude of the star, where it is.
Yeah.
And then you've got its position in the circle.
Right.
You know, east, west, around like that, that area. And then it's up and down.
And is that then that point from where you are on Earth as to what those measurements
so it's based on that. Yeah. So you look there and the star that's there has its own address based upon where it is there and where it is in the great circle.
Yeah. Okay. Okay. Thank you.
Yeah, it's like a GPS address.
Yeah.
And that's how telescopes work. Not the telescope I use because I do it by eye, but the big telescope.
Yes.
My 40-inch works. I dial in an address.
Yes.
And it goes to the location.
Right.
That's how it finds it.
Yeah.
Whereas the way I do it, I just look and say, okay, I want to go there.
Yeah. And you have to have a map.
Yeah.
To be able to make those comparisons.
Exactly, which is what this was all about, was to provide the Southern Hemisphere map. Yeah. So it had an IP scale which drastically reduced the time to measure it all because it's a really tedious job. So the painstaking measurements were made by hand by groups of women known as computers or measurers and became recorded in what became known as ladies' logs. Again, paternalistic, but this is how we know who did what, where and when. Yeah. So that's a picture of the machine there and a picture of one of the maps, the plates. So you can sort of see the area that they were working in. And this data is still used today. This isn't like outdated. This is used to compare things, and that's a talk for another day, but on how we've progressed. So here we have the Southern Astrographic Catalogue Plate Measurers. And so this is in the period 1891 to 1963. And so Adelaide had 2 lady computers for those 8 years. Sydney Observatory had 22 lady computers between 1960 and 1963. And a couple of those ladies worked a very, very long time. Melbourne had 26. Perth Observatory had 10, and this is in comparison to the Royal Observatory in Edinburgh. Yeah. Right, just to give a comparison, who had 12.
Right.
So Australia employed far more females to do this work than anywhere else.
So the term computers is a really interesting one, Donna, because it came up in the movie Hidden Figures. We see it as a machine and sort of see it as a derogatory term, but it's about computing numbers.
It's a numbers thing,
and so that came first, and then the machine name came after.
Yeah, because we didn't have adding machines or anything like that.
It's a bit like having a stenographer or a lady who does the...
Well, we had scribes. Remember, we had scribes.
And then also, what's the one where they do the shorthand?
stenographer.
Yeah, it is a stenographer.
And now it's so easy.
Yeah.
So this is just showing how much work was actually done. Again, comparing 3 of our observatories with 4 of our observatories with Edinburgh. Yeah. So, like Sydney Observatory in those years, they catalogued 740,000 stars on 1,400 plates with the 22 ladies. Whereas the Royal Observatory did 194,000 in 139 plates with 12 people. I mean, the work that the ladies in a much shorter period of time. So the work that the Australian ladies did was amazing and incredible. And those are the catalogues that, as I said, even I use today.
Right.
So this is a couple of articles out of the paper at the time. Okay, this is 1902. First in the 1913. So this is from the Brisbane Courier. Their hours are from 9 to 5 on weekdays to noon on Saturdays, an hour being allowed for lunch. Their salary is £40 a year. The editor has only one remark. No man would undertake it at more than double that amount. So they were paid by the government, and so they fell under all the government rules. And this is where the problem came in. Because if you got married, you had to leave.
Yes.
Certainly when you had a baby, you had no choice. Particularly if they didn't think you were married, that was even worse.
Yes.
So many people hid their marriages and things like that, as we'll see.
Yeah.
But it was a shame because people who were really brilliant at the job were lost because they got married.
Yeah.
And it was a shame you have to choose.
It makes a bit like teachers as a whole.
And it was, yeah. But these were getting paid less than teachers.
Yeah.
So this is 1913 from Perth. The minimum fee of £40 was inadequate for the class of work, which is of a technical character, so much that the first 6 months is spent learning. And so it was actually up to £96, which was still less than teachers, but a lot better than what they were getting. So here's just some examples of some of the people who actually did some stuff. In 1880, John Tebbit employed a Miss Arnold, a school teacher, to carry out some of his more laborious astronomical calculations. John Tebbit was an amateur astronomer who got a grant from the government because he found a comet, as you do. I didn't get a grant from the government, I found a comet. In 1890, of course, Charles Todd employed a female computer, Mary Emma Greer, who I'll talk about in a little while, and a second computer called Miss Pittman in 1892. And Charles Todd was a lot ahead of his time too. Yeah. I mean, he was very busy as well as being the government astronomer for South Australia. Cecilia McKellen contributed media reports to the Society for those 2 years, and that's recorded. So a lot of this is hard to find the records because, again, things were done. Miss C. Pearley worked at the Melbourne Observatory from 1898 to 1918 on the astrography catalogue, and Miss Winston Bellamy worked on the astrography catalogue in Sydney for 20 years. Yeah. Okay, those two ladies. So we'll just go a couple of other people. This is Mary Ackworth Orr. Now, she was from England. She moved to Australia in 1890, and in 1897 she worked with Tebbit he was out at Windsor, Hawkesbury, and published An Easy Guide to Southern Stars, a book so people could know what the stars were in the sky, a book for children and for people just learning. Yes. It's not, I've seen a copy of it. It's actually really interesting. Right. I mean, given you didn't have all the civilised things we've got today, it's actually really good. And she also made observations of the sun, moon and planets. She then finally married an astronomer called Evershed and moved to India, where she continued her work, but was lost to us, of course. This lady, I don't know, she's probably not an astronomer, but I like her. Mary Morton Allport, she was from down in Tassie, and she made this drawing of this comet of 1843. So
that's what, obviously, she saw it.
She saw it, yeah. It was pretty. This was a pretty spectacular comet.
It was a pretty specky
comet. But she made drawings of it. There's not a lot of drawings from Australia of comets and things like that, of celestial events in those times. And so this lady did them. And we come down to Mary Emma Greer, who, as I said, was employed by Charles Todd. And here you've got a picture of her with Todd, Cook, and herself. And I think she looks. I actually struggled to work out which was a girl first, so I'm pretty rude there.
Oh no, I know, but straight away.
Yeah, that's because
she hasn't got a moustache.
Exactly. So her significant contribution to astronomical was highlighted. So she did amazing work. She did measurements and everything else, and she actually fixed telescopes. She did the recording. She actually made real observations through the telescope, not just working on the plates. She actually took the observation, something that was unheard of. Right. But here you get the after she's left because she got married. Yes. What he wrote was, since Mr. Griffith's marriage, which has deprived me of Miss Greer's services, we've been unable to observe any of your astrographic stars. Wow. Because without her, he had no one to do it because he was too busy running around doing his stuff. Yeah. You know, so these are records that she took, and there's this sort of telescope that she was using. And it's not like today's telescopes. So these days everything's civilised. You do it all on a computer. Yeah. You know, you don't have to climb down like this and get underneath and everything else. Yeah. It's very uncomfortable observing in those days. Right. It was very challenging work, and of course you're working in the dark because remember we didn't have good lighting or red lighting or any of those
so
things.
it would have just
We
been
had
a
today.
candle or a
Yep,
lantern
or a gas
something.
lamp.
Yeah.
Or whatever they call them these days.
Okay.
So sex typing and original work, I mean, that's probably a bit thing, but because it was sort of such tedious work, that's what women were given to do. They weren't allowed to do that, but they worked their way into it.
Yes.
But again, they didn't get recognised for it. So here's some ladies working. You've got Mary Ellen and Ethel Wilcox working, and Winsome Bellamy on this side. And you can see they're sitting there. One's doing that, one's recording.
Yes.
Okay, so this is about Charlotte Emily Peely, I can think of. She is a measurer computer and the manager of Sydney Observatory from 1898 to 1918. So she actually progressed to being able to run Melbourne Observatory. And so there she is in there.
Looks like there's two ladies in that picture.
There is one on the right, Jen. I couldn't find out who she is.
Yeah.
Okay, this is Sydney Observatory computers in the 1950s.
Mm-hmm.
Men are pretty gross, serious, aren't they? Okay, so there's Winsome Bellamy. So she joined the Sydney Observatory astrographic team in 1948 and worked there till 68. She catalogued 43,000 stars twice. Now, the reason it was twice is we did positive and negatives.
Mm-hmm.
So you know you've got a negative.
Yeah.
So she do that because you can see things differently, and then also in the positive where you make the actual print.
Right.
So because you can see different things, so she catalogued them twice.
Wow.
So that's pretty incredible by hand.
43,000?
Yes.
Over 20 years?
Yes. That's a lot for one person to do. And this went into the catalogue. And this is her at the 2015 opening of Sydney Observatory at East Dome.
Fantastic.
But she had to choose her career over marriage.
Right.
So Kathleen Rachel Mackinson from 1917. Here's a lady who, because of the First and Second World War, she'd done her studies and everything else. She'd got a degree and everything else. But she was teaching radio physics to the young men who were involved in the new science of radar.
In terms of
so she was in great demand.
Yeah.
But as soon as the war finished, there was no work for her.
Mm.
She couldn't work it. And then she married a fellow who worked in the same location. And apparently men and women couldn't work together. Fathers and sons could work together, but husbands and brothers could work together, but not husbands and wives.
So
she had to go and so she went and worked in wool research.
Right.
Rather than in the physics, because her husband worked in that.
Yeah.
And okay, but to 1977, she's 60 years old before she became and to see the first woman at CSIRO become a chief research scientist.
Right.
So that date, 1977. I mean, we were at school then.
Yeah.
And I mean, who'd have thought that it was that late before the first woman to be a chief research scientist at CSIRO.
Right.
So this is the sort of thing. I'm going to go down to Canberra now. Priscilla Bock, obviously not an Australian, lived in Australia with her husband Bart, who's very popular.
Yes.
I mean, these are the mother and father, the grandparents of Signing Spring.
Right.
Because he got Signing Spring here. But she co-authored a number of papers with him. She was an astronomer in her own right.
Yeah.
She did amazing work. She used the telescope. She used the old telescope I've got back in 1963. They spent a lot of time up there until they had to move back to.
When you're saying the telescope you've got, you're talking about Milroy Observatory. That's just out.
That was the 40-inch because they got that. That was the first telescope, of course, at Signing Spring, and they spent a lot of time there.
Yes.
One day I'll tell you a ghost story. So they moved to Australia in 1957, and they spent many, many years doing it. And after her death, she was commemorated by an asteroid. But again, most people know Bart Bock.
Yes.
But she was well loved of so many people, and she did so much work.
Yeah.
Now this lady is incredible. This was the first radio astronomer lady. This is the first radio astronomer, not lady, radio astronomer in the world, perhaps. Yes. Definitely in Australia.
Yeah.
Her name's Ruby Violet Payne Scott. She was a physicist, radio astronomer, and a school teacher. She ended her life being a school teacher.
Right.
In 1933, she got first-class honours in mathematics and physics, was hired by the fledgling CSIRO to investigate radar. Again, notice that's in the Second World War dates.
Yes. Okay,
1945, she worked on the first radio astronomy in the Southern Hemisphere. Her and a couple of the guys, Borsey and the like, built an 11 centimetre observation. So that's in a particular wavelength of the sky.
Yeah.
But they did it, the first to be done. She got married, and then in 1950 lost her job because they found out she was married. She was married for 8 years before they found out. Yeah. Unfortunately, she had to leave because she was expecting a baby. And it's a bit, apparently, having a baby out of wedlock was really bad.
Yeah.
Having a baby in wedlock meant they found that you were married. So you had to own up to being married because it was better than the alternative.
That's amazing what a hidden life they've had to lead to
to follow
to
their
be able
passion.
to follow their dreams.
Yeah.
And then, of course,
contribute
when she
in
left
work.
radio astronomy, she went into teaching, which was great for the schools. But what a loss it was to
Yeah.
Australian astronomy.
Yes.
And I mean, we're talking the 50s.
Yeah.
We're not talking, okay, it is last century, but, you know, it's not that bad.
Yeah.
Betty Louise Tuttle died in 1990. Science degree from Adelaide. She was a student of Westerlund and Bart Bok down at Canberra. She did a thesis on planetary nebula, which is still cited today. But she had to leave, like a lot, even today, you have to leave the country. She went over to England, studied under Woolley, and discovered a black hole. By the way,
yes,
the Mrs. Payne and this lady probably should have got Nobel Prizes.
right.
But like one of my other heroes, missed out.
Yes.
The blokes got them. Anyway, she returned to Australia in 1970. She worked here in Coonabarabran. She worked up at the AIT, so this is another local area that you didn't even know about.
No.
But she worked up at the AIT until 1978. Remember that the telescope was finished being built in 74. She came over here to work on the final parts of it because Woolley was very much involved.
Right.
He was the Astronomer Royal. And remember, it's Anglo-Australian.
Right.
So that was the Anglo part.
Yes.
And getting involved. 1978, she went to work for the University of New South Wales, where she was really important in physics outreach and astronomy outreach, as well as teaching it. And she also helped to get the Automated Patrol Telescope up to Siding Spring, the little UNSW telescope in 1989, which did amazing work in planet search.
Mm-hmm.
And again, like I said, I bet you didn't know she was from came to Coonabarabran. Anne Savage, of course, you do know.
I do know.
Okay, and she was an amazing lady, came out from England to do radio astronomy, went down to Parkes, did some incredible stuff, worked on quasars, again, made some significant discoveries, went to work on the UK Schmidt Telescope, become the astronomer in charge there.
Right.
As a lady. But basically what her job was you got the radio signals, then she matched them up with the actual...
The images?
Images, yeah.
Yes.
The physical stars to find out, because nobody knew what quasars were.
Yeah.
And quasar means a quasi star. So anyway, it means quasi because they didn't know.
Right.
So it's sort of like this, you could hear it in radio, you could find it in radio, but you needed to match it up then with an actual
what is it
object.
Out there?
Yeah, because you can't have, that's how black holes work out. They have these noises, but
Right.
what were they?
Oh, so black holes make noises.
Black holes
a whole
are really,
other topic.
that's another topic. The black holes are really noisy.
Yeah.
And it's like Jocelyn Bell. But now, who's going to be here in Parkes in July? I'm going to meet her.
Right.
Cool. She's one of my absolute heroes. She discovered pulsars.
Right.
Yeah. Remember we've talked about
Well,
in
this
the
was
past.
the pulsars were talked about too in the on the
Well, she
ABC.
discovered pulsars.
Right.
The first pulsar, she discovered it.
Yeah.
Her supervisors got the Nobel Prize.
I think we heard a pulsar.
They sound really good.
Mm.
They're like the
it's
atomic
almost
clocks.
like a pulse.
Well, they are.
pulse,
They're the perfectest timekeepers in the universe.
Yeah.
They're amazing things, but she missed out on the Nobel Prize, but like I said, she wasn't. And this lady.
I do know Rabina.
And did you know that
That's
Rabina
right.
was an astronomer for 35 years?
Yes. Well, not for that long, but I knew
She was.
she was
She
involved
came
in
here. She
astronomy.
moved here in 20 years ago, and that's why I said I left my typo on there, to work at the Anglo-Australian Telescope.
Mm-hmm.
Okay. She worked in CSIRO before that in cloud physics. She finished uni and needed to get a job. She had a choice. She applied for 2 jobs and got into cloud physics.
Right.
And then she worked at the radio telescope down at Parkes.
Yes.
And then for years she looked after him up, even after she retired, because she had to retire in 2000 because that was before when she was 60 and age,
Right. Yes.
or whatever, when age comes in.
Yeah.
You had to retire at 60,
Mm-hmm.
compulsory. Now that is, you can work forever.
Yeah.
But she was still called on many, many times to fix mock for it.
She's still working.
And she's still working in different fields. And I think she's an amazing lady.
Yes.
But another
yeah.
local person, again, that people just are very quiet, unassuming thing.
Mm.
Okay. And I had to put this one in. This is Comet Siding Spring. This is my comet.
Your comment.
This is my comet. Yes. It's called Comet Siding Spring because it's named after the survey.
Uh-huh.
I have 2 of those, but the next one will have my own name because I'm going to find it by myself without a survey.
Right.
So that's my comet I discovered.
You can claim it for yourself.
Yes. But you know the funny story about this, don't you? Have I told you this story?
Well, tell the listeners.
I've got really quick.
Yeah.
I'm going to tell the listeners. I discovered this comet in 2006.
Mm-hmm.
Okay. Nobody except my immediate husband and friends who actually knew gave a comment about it all. They didn't care. No one cared. I cared. Google cared. In 2010, NASA's WISE satellite took a picture of it.
Right.
It was one of the first. It was actually the first photo that they released from the WISE satellite. So it got all over the newspapers. So I've got my 15 minutes of fame. And then, so it was on the front page of the Sydney Morning Herald. Underneath of it, because I hadn't seen that, somebody sent it to me, because I don't read the Sydney Morning Herald, it said, ANU astronomer Donna Burton, first female to discover a comet. So I was employed as a research assistant, right? Like, as you do.
Yeah.
You know. So I contacted them. Oh, now I'm an astronomer. Can I get more pay? That didn't go down very well. But I thought it was really funny. It wasn't until 2010 the ANU even acknowledged what had happened. So, you know, I'm not saying that that's like what people suffered and things, but it still happens. Today. So I'm going to finish with a couple of quotes. Vera Rubin was not an Australian astronomer. She died last year, radio astronomer. Again, someone should have won the Nobel Prize in that. But I love this quote. I live and work with three basic assumptions. There is no problem in science that can be solved by a man that cannot be solved by a woman. Worldwide, half of all brains are in women.
Yes.
3, we all need permission to do science, but for reasons that are deeply ingrained in history, this permission is more often given to men than to women.
Yes.
So, and then we'll just finish off with Helen Keller. It's got nothing to do with science, but you've got to admit, this is pretty cool.
Yes.
Right? No pessimist ever discovered the secrets of the stars or sailed to an uncharted land or opened the heavens to human spirit.
Yeah.
We've got to get out there and do it.
That's
So
it.
thank you, and thank you for giving me a go. And if anyone's got any
my
questions.
pleasure. Not sure if there are any questions. Certainly we can have discussions in Facebook. Yes.
And I went too long.
And no, that's fine. We had a bit of a technical interruption in midway, so I figured that was fine. So didn't want to stop you in the flow because that was so fascinating. And I don't know, so what, anyone can ask questions in the text, but Donna, I want to say a huge thank you for sharing your knowledge. It's really fascinating, and there's just so many more things we can be asking. It's brilliant how we have so much to learn about the world around us.
That's why it's such a cool science.
Yeah. And it's brilliant that women are involved, and we need to be really aware of them being more recognised. And Maddie's just put a little comment here, no questions, but I never realised how many incredible women we had lost due to marriage and children. Wow. Yeah. So we're living in a different world to what most of these women did, but I still think there's a level of
There's still
recognition we need.
You have a whole two-body problem still, though, these days. So, like, my husband's in IT at the telescope.
Yes.
I'm in astronomy. I don't have a job up there, but we're here. I've got to find my own job. But we move from here. What do we do?
Yes.
And so many women done that. I know a lady who finished a PhD. She's married to a significant person now in that. He's just finished his PhD postdoc. But she's gone and studied medicine.
Yeah.
Because there's no way they could both get jobs somewhere.
Right.
But as a doctor, she can get a job anywhere. Mind you, she's awfully clever.
Yeah.
But that's sad. So this is still happening. This is in the last couple of years.
Yeah.
So it still happens. The two-body problem is a big problem in astronomy.
Yes. And probably because there's not that much employment in the field in the first place.
Yeah.
And so
there's only 10,000 professional type astronomers worldwide. And that includes people doing what I'm doing. Yeah. Not doing research.
Yes. Yeah. All right. Fascinating and interesting, and wow. Now there's a question Maddie's got, wondering how many women are involved in astronomy now in Australia.
So it's about 15%. We're a lot more.
Right.
There's only around 200 of us. There's only 200 in total in Australia, really, employed.
Right. Yes.
And probably around 20, 25% at the most, probably less. Radio astronomy has picked up and helped a lot.
Right.
But like I know people who've done their PhDs in astronomy who are now doing computing, data work.
Yeah. Instead. Yeah. Yeah. Okay. All right. Let's wrap it up. Fantastic live at lunch. Thank you, Donna the Astronomer, for being our special guest. And I love that new title. That's exciting. Have a great week, everyone. And we'll post out what's going to be the new topic for next week. It's going to be about Canva, in fact. Okay. And Maddie said thank you for your passion is fantastic.
Thank you, Maddie.
Terrific. Have a great day. Have a great week. Bye.